This is Pre-Calc section 6.8. This is the third video on partial fraction decomposition. This video is going to deal with some quadratic factors. We have not seen that before. When you look at this denominator and the numerator, of course, you have to look to see, do you have to do any long division? And the answer is no, because the numerator degree is not greater than or equal to the denominator degree. So we're good for just breaking this up. We know we have a over x, b over 3x plus 5, and there's our other denominator, 4x squared plus 5, but I have not filled in the numerator. It is not a plain old c. That's what you might think it is, but it is not. When you have a quadratic factor, the numerator is this, cx plus d. So your numerator degree is 1 less than your denominator degree. This is x to the first. This is a plain old number. Therefore, this is like ax to the 0th, and that degree is 1 less than this. So this has to be cx to the first. That degree is 1 less than this. So that's what we have set up. And we know we need to multiply through by the common denominator, which I've already written this up to save us some time. Common denominator is going to cancel with that whole denominator, and all we're going to get over here is 1. And here we have 3 different things to look at to cancel out. So when I have a denominator of x, that's going to cancel with this x right there. So what I have left is a times 3x plus 5 times 4x squared plus 5. We're not foiling that out or anything. We're just writing it down right now. When we get ready to come over here, the 3x plus 5 is going to cancel. So cover up the 3x plus 5, and what we have then is b times x times 4x squared plus 5. And the third thing, the 4x squared plus 5 will cancel with that 4x squared plus 5. So I cover that up to get that out of the way, and we have cx plus d times x times 3x plus 5. So that's the whole expression that I have to deal with now to see if I can solve for a, b, and c. So over on this side is the same thing I wrote by hand. It's just a little bit neater to look at. We are going to let x equal 0. And the reason we'd like to let x equal 0, if we do that, we can make some stuff cancel out. So if x goes in as 0 here, then 0 times all of this makes this go away. And if x goes in for 0 here, here, and here, it makes all of this go away. So all I have to really do is plug in 0 here and here and get that simplified. So this is 1 equals a times 3 times 0 is 0 plus 5 is 5. 0 squared is 0 times 4 is 0 plus 5 is 5. Clean that up, and we have 1 equals 25a. Solve that for a. A is 1 over 25. So that's one value. B, I'm going to let x equal negative 5/3. Because if I let x equal negative 5/3, if I put negative 5/3 in here, 3 times negative 5/3 is negative 5 plus 5 is 0 right here. So all of this goes away. If I put negative 5/3 in here, 3 times negative 5/3 is negative 5 plus 5 is 0. Multiply 0 times all that, that goes away. So all I have to do really is put negative 5/3 in for that x, and then clean it up. So this will be 1 equals b times negative 5/3. And in the parentheses here, I need to square negative 5/3, which is 25/9 times 4 plus 5. Of course, you can use your calculator on this. You could stow negative 5/3 as x and then type in 4x squared plus 5, or you can type in 4 parentheses negative 5/3 squared plus 5, and then convert it back to a fraction, and this equals 145/9. Then multiply here, negative 5/3 times 145/9 gives me negative 725 over 27 b. And to solve this for b, divide both sides by negative 7/25 over 27, or the easier thing to do is to multiply by the reciprocal, which is 27 over negative 7/25. That's going to cancel out, and we end up with this value for b. b equals negative 27 over 7/25. Now, we don't have another, what I would say, good value for x, because there's nothing else that's going to create a 0 for us. When you look here, there's no value you can put in here for x that creates 0. Now, I could just put in 1, which to me is probably the easiest arithmetic. I could put in 2, 3, 4, whatever I want, but 1 works out to be the easiest arithmetic. Now, these next several steps are just going to be a whole lot of arithmetic that you've got to be careful with your signs and with your copying. 1 equals a times, put 1 in here and 1 in here. 3 times 1 is 3, plus 5 is 8. 4 times 1 is 4, plus 5 is 9. 8 times 9 is 72. Then put 1 in here and 1 in here is going to give me a b. Times 1 just stays b. Put a 1 right here, gives me 9, so this is b times 9. Then put a 1 in here, here, and here. Now this is the parentheses c plus d, because c times 1 is c, times 1, I can ignore that, times 3 times 1 is 3, plus 5 is 8. Now clean that up a little bit. A times 72 is 72a, plus 9b, then distribute this. 8c plus 8d. So the only way I'm going to simplify this a little is to substitute in these values for a and b I have already gotten. So 1 equals 72 times a, which is 1 over 25, plus 9 times b, which is negative 27 over 725, plus 8c plus 8d. Nothing I can do with that right now. I'm going to clean this up. 72 times 1 over 25 is 72 over 25. 9 times negative 27 over 725 is negative 243 over 725. Still, plus 8c plus 8d, and it's still 1 over here. So what I did then is I used the graphing calculator to go ahead and subtract 72 25ths and add 243 7/25 over to this side. So this is minus 72 25ths, gets rid of that, plus 243 over 725, gets rid of that. So this side says 8c plus 8d. This is just straight calculator, and this is negative 224 over 145. And I happen to notice that there's an 8 here and an 8 here, and that 8 divides evenly into this. And to make my next step easier, I divided everything by 8, which gives me this equation. Negative 28 over 145 equals c plus d. Now, you didn't have to do that division. I just wanted to get the numbers a little bit smaller. Notice there's 2 variables here. I can't substitute anything else in. And if you've got 2 variables, you need 2 equations with 2 variables. So I'm going to have to do the substitution thing up here and choose another value for x and do all of this work and substitute in the values I have for a and b. So over here on this next screen, here's my expression right here. This time I let x equal 2 because I felt like that was going to be the next easiest arithmetic. So 1 equals a times, I'm putting 2 here and 2 here. 3 times 2 is 6, plus 5 is 11. 2 squared is 4, times 4 is 16, plus 5 is 21. Putting 2 here and here, I will have 2 times b. And inside here, 2 squared is 4, times 4 is 16, plus 5 is 21. I'm putting a 2 in for this x, and this x. So this will be 2c plus d times 2 times 3 times 2 is 6, plus 5 is 11. So arithmetic here, 11 times 21 is 231a. 2 times 21 times b, this is a plus sign, is 42b. And then here, I did 2 times 11 is 22, and then I distributed 22 through here. So 22 times 2c is 44c. 22 times d is 22d. And this is still equal to 1. I have to substitute in the values I know from a and b. So if I plug in the 1 over 25 for a, put 1 over 25 in for a, I get 231 over 25, plus, if I put in my b value, which was negative 27 over 725, I get negative 1134 over 725, plus 44c plus 22d, and this all equals 1. I need to get these numbers over on this side, so subtract 231 over 25, add 1134 over 725, and you will get negative 968 over 145, and that equals 44c plus 22d. I notice over here that these are both divisible by 22, so I used the calculator just to check that maybe 968 was divisible by 22, and it is. So I divided both sides by 22, and I got this down to negative 44 over 145 equals 2c plus d. Now, we've got one equation on this page with c and d in it. We have another equation on this side with c and d in it. We can use elimination or substitution to solve those together. I brought over the equation from the other page here in red, and now I want to use elimination on this. So what I did is I multiplied this top equation through by negative, because that turns this to positive, turns this to negative, and turns this to negative, which is going to make the d's cancel out. So if you add these together, you will get 16 over 145 equals negative c. And if negative c equals 16 over 145, positive c equals negative 16 over 145. So there is a value for c. To get our value for d, I'm going to use this equation right here because it's the easiest one. I have negative 28 over 145 equals c, which is negative 16 over 145, plus d. Add 16 over 145 to both sides, and I get negative 12 over 145 equals d. So this is a brutal problem for just plain old algebra simplifying, and fractions you just got to be very careful with every step. So now I just need to put it all back together again into the equation. There's the template of our equation. A from a previous page there was 1 over 25. The b value we got was negative 27 over 725. And c was negative 16 over 145 times x, plus d, which was negative 12 over 145. So cleaning this up, I have 1 over 25x plus negative or minus, whatever you want, negative 27 over 725 times 3x plus 5. Probably for Math Lab, they would prefer a minus right here. And then plus negative 16x minus 12 over 145 times 4x squared plus 5. An option on this part right here is to put a minus there, but that minus would distribute to the whole top, and this would be 16x plus 12 over that 145 over 4x squared plus 5. And these fractions would stay the same.